Hi guys. Second video, I forgot to record the sound on the first one. A couple of things coming up. One is this is the last lesson on electricity. Second thing is I'm going to run a test on Friday, and it's going to be as a Google test. So it'll be normal posting, and you log in, it'll collect your email address so I get correct names. So let's finish off. I'm not entirely sure whether I covered this. I know I didn't do it in person, but I think I may have left it as cover. I don't know. But I figure if I do it, I know it's done for sure. So it's all about resistors in series and parallel. So resistors in series first is really easy. We've done this quite a bit in terms of light bulbs, but let's just be really certain what we're on about. So we'll take a resistor and we'll apply voltage. So let's give it 10 volts, and we can apply an ammeter, measure 2 amps, and that gives us a total resistance of 5 ohms. But the question is, what happens if we start adding more and more resistors in series? So let's have a look. So if we shrink that down, shove that over there, and put one there, copy it, paste another one in. So no prizes for guessing what happens. You now have an effective resistor of 10 ohms. And so if we were to graph this, a nice simple little experiment, and we did a number of resistors over at the bottom, number of resistors, and we did resistance in ohms up the side, what we would see is with one resistor 10, 5, 2 resistors 10, and 3 resistors 15, like so. That was my kid putting Peter Rabbit on loud. Line of best fit, linear, straight through. So no great shocks there. Where it is a bit more counterintuitive is when you get to parallel. This is why I'm doing the video. Again, the idea that you add more resistors and get more resistance, well, doesn't hold true in this case. So we'll take another one of these, we'll take a nice big ammeter, we'll plug in one at 10 ohms and put in a voltage there. So if I want 10 ohms, then I'm going to need 10, something divided by something is 10. So let's go 10 volts, 1 amp. So what happens when we put more resistors in parallel? So let's draw the axes ready. In fact, yeah, redraw, I won't copy it. Number of resistors and resistance. Well, let's add one on. So we'll add another 10 ohms. Will it be 20 ohms? And the answer is no. And that's all to do with charges flowing. So if I draw myself a little charge and I grab it, my charge as it flows has one of 2 pathways now. It's going to get to this junction here, and its choices are to go through the first resistor and return, or go through the second resistor and return. And that means twice the current can now pass through. And so what you end up with is 2 amps flowing. And if we use Ohm's law, we get 10 volts over 2 amps, and we find the resistance is actually halved. So it's a clever trick in electronics that if you want half the resistance, you just put resistors in parallel. So with one resistor, you might end up with 10 ohms. However, with 2 resistors, we end up at half of that, we end up at 5 ohms. And if we add a further resistor, we end up reducing the resistance even further, so 10 ohms, like so. And you get half of a half of a half, and it just keeps going. So it's an exponential decay curve. So in this case, we should get, I think, 2.5. And so the funny thing is, the more resistors you add, the less resistance you get, which is counterintuitive from when you look up at the series circuit. And again, the key phrase here is these pathways. So with the addition of more resistors, there are more pathways more pathways for current to follow. And hence more current flows. More current flows, therefore less resistance in the whole circuit. In the whole circuit. And that concludes this lesson. Everything you need is on pages, I'm going to quick look now, should have prepared. It's on page 30 at the bottom. It says practical at the top. Investigating resistance. So it shows you both circuits and how to do it, and the two graphs that I've drawn so far. Any questions, leave them in the comments. And test is to go up on Friday. Get revising. Oh, and there'll be a Zoom revision live Thursday afternoon. I'll post the time and the date in a bit. Cheers.